Productivity, a common goal in today's industries. It takes quality tools, quality equipment, and of course, quality people. But there's another quality that's easy to overlook, yet without it, a business can grind to a halt. Good lighting helps people do their work efficiently, accurately, safely, and comfortably. It's not an easy job because every job is a little different.
Industrial tasks are considerably different from office tasks. In an office, the task is performed generally in either a horizontal plane for regular paper tasks or on a vertical plane for VDTs. But in an industry, the tasks may be on a horizontal plane, they may be on a vertical plane, they may be at any plane in between. In addition to that, the industrial tasks are generally three-dimensional in nature, so that it's necessary to get a different quality of lighting on an industrial task than it is on an office task.
It may be more challenging in an industrial environment, but good lighting is a good investment.
If you talk about the environmental influences on a person's productivity, you have many, many items. It may be the temperature of the room, or the color of the wall, or the size of the workstation. But clearly, lighting is the most important of them, because so much of our activity goes through our eyes, and from there to the brain to our hands. Yet lighting is the least expensive of these environmental influences.
To build a manufacturing space costs an average of about $100 a square foot. Assuming an employee occupies 100 square feet of that space, the annual cost of that worker in wages, benefits, and related expenses is about $400 per square foot. The annual cost to heat and cool that space, about $2. And the cost to light that space? Only about 50 cents.
By looking at the relative costs, it becomes apparent how important and how effective it is to give a working person outstanding lighting for the performance of his tasks.
We believe that productivity is definitely increased because of the lighting system. It's much easier to use the machine tools and to read the blueprints and to inspect the parts. I think we find that it's better on the people's eyes. It's much less glare, and it's just a more open and well-lit atmosphere for our employees.
Let's look at some basic principles of good industrial lighting. One obvious requirement of good lighting is to provide the right quantity of light or illumination on the task.
The foot candles in the old plant averaged around 80 foot candles with areas that were as low as 25 to 30 foot candles. This plant was designed with a 135 foot candle level at tabletop level for the operators.
The Lighting Handbook, published by the Illuminating Engineering Society, provides tables of recommended foot candle ranges for different industries and tasks within those industries. Determining where your application falls within these ranges depends on many factors. For example, use higher light levels if speed and accuracy are critical. Provide more light if there's a lot of dirt in the environment to collect on the lamp and fixture surfaces. Use lower light levels the more the contrast between the task and background. And younger employees generally require less light than older employees. Tailoring the guidelines to your situation should ensure good quantity, but having enough light isn't enough.
The uniform illumination within a space, in my estimation, is critical. We do not try and produce average foot candles. We try to address a uniform foot candle illumination level so that the pupil doesn't have to work as hard. Uniformity in that you can take your light meter and place it just about anywhere within a given space and not see the light meter go plus or minus 5 foot candles. That's uniformity.
One way to achieve uniformity is the proper selection and spacing of luminaires.
The lighting is a metal halide lighting system, and they're on 15 by 17 foot square grid pattern in straight lines. The diffusers that we have, the luminaires, have a good distribution of light, and we've found from our measurements that it's pretty even all over the plant.
Fixture manufacturers provide recommended spacing to mounting height ratios or spacing criterion to help you achieve uniform foot candles. Fixtures with a narrow beam spread spaced too far apart create puddles of light. As a result, the workers' eyes tire as they constantly adjust to the varying light levels. The problem can be solved by spacing fixtures closer together or creating a wider beam spread. Wide distribution luminaires are especially effective at mounting heights of about 15 to 35 feet above the work plane. They provide good modeling of tasks and get into all the hard-to-reach places inside machinery. But they also raise another concern.
Now, one of the problems that you have with a wide distribution luminaire is that that luminaire is going to provide a higher glare component to the worker than you would get from a very narrow distribution. One of the ways to overcome the negative effects of this glare is to make sure that the ceiling plane is well lighted. We light the ceiling of industrial spaces by using luminaires that allow some of the light to escape out the top of the fixture. That will then tend to modify the difference between the ceiling plane luminance and the brightness off the fixture and make the glare less noticeable to the worker. Ceiling plane luminance can also be improved by making sure that the ceiling is painted a light color, because light colors obviously reflect more light.
Glare takes two forms: direct or discomfort glare and indirect or reflected glare.
Discomfort glare results when you have uncontrolled light. You have too much light coming into your eyes. That kind of glare can usually be solved by shielding the lighting equipment, by diffusing the light, by properly sending the light in the right direction, or moving it out of your field of view. Indirect glare or reflected glare is an insidious problem. And the reason it's insidious is because it reduces the contrast on the task. This is the kind of glare that results when you look at something and there's a sheen or a shininess to it that masks what you're trying to see. To solve that problem, you need to really examine the task and its relationship to the lighting system. Often just moving the task slightly one way or another will reduce reflected glare. And other times you may have to change the task itself. So glare is always a problem when you have either electric lighting or day lighting. And glare can be solved in very practical ways given the talents of a good lighting designer.
We wanted to keep the color rendition in the plant alive, and the metal halide gave us as close for an industrial lighting system to outdoor natural lighting as we could get.
People like to see things in a normal, natural way. So if fluorescent lighting is being used, we would recommend the use of SP or SPX fluorescent lamps, both of which have good color. Both types of lamps will make things look fairly natural and normal, but of course the SPX will do the best job. Or perhaps where you are doing some kinds of inspection where better than average color rendering is needed simply to see the difference between, let's say, a yellow wire or a red wire on a printed circuit board, where you need very precise color rendering. Perhaps in graphic arts problems, we have some special lamps in the fluorescent area. These are the Chromaline lamps, the Chroma 50 and the Chroma 75. They have the highest color rendering index that it's possible to make these days with fluorescent lamps.
HID sources also offer color options.
If color is critical, we suggest the metal halide multivapor for the area. If performance and production are not color critical, we suggest the Leukolux. But we give the customer the opportunity to make the choice, and many, many times we'll show them an area of each. And they can look at that and make a determination, so there's no surprises when the light switch are energized.
One of the trends that we have seen in industrial lighting over the last 10 years is a very definite move toward the use of high-intensity discharge lighting. This is done for many reasons. It's more economical to use HID systems. It can be energy efficient, and maintenance on an HID system is much more economical. Now, all of these are very good reasons to use HID systems. However, I also think that it's very important that we balance the characteristics, and we know the characteristics of those systems and the limitations of them, so that we apply them properly in every instance.
So we have three types of HID lamps: mercury, metal halide, what we call multivapor, or high-pressure sodium, which is what we call Lucolox. Now, mercury is an obsolete light source. We don't talk about it anymore for new installations, and it's rapidly disappearing from industrial lighting use, and it should, because it's less economical than any of the others. High-pressure sodium is usually the most economical choice for industrial lighting because it has the highest efficacy, or lumens per watt. It also has very long life, 24,000 hours, which in industrial lighting applications usually means 5, 6, maybe 7 years of operation. The next step there, and the one that's going to be most exciting, will be the improvement in color. Metal halide, or multivapor, is growing because it has good color and high efficiency. And what we're doing now is taking the next step so that we can provide more color variations. And along with that, it's becoming available in different sizes, smaller sizes particularly.
Fluorescent systems continue to be popular as well. The reasons?
Fluorescent lighting tends to make people feel quite comfortable in an industrial environment because the light is soft and diffuse, tends to be less glaring, tends to require a less complicated fixture to shield the glare. We pioneered a few years ago in the development of fluorescent lighting for industrial facilities with the introduction of the so-called power groove lamp. And it's still the most powerful fluorescent lamp made. Per inch of lamp, that means it delivers the most lumens per inch. We've also come out with more efficient lamps, particularly the compact fluorescent lamps we call biax or biaxial lamps. And so if you add good color to that, well, you make a very pleasant environment on a workbench or in a workstation or even in a whole factory.
Another factor that affects the choice between HID and fluorescent is the mounting height. Fluorescent systems are most effective at mounting heights of about 5 to a maximum of 18 feet above the work plane. HID systems can be effective in both low bay and high bay applications, from about 8 to 100 feet or more above the work plane. Low bay fixtures usually have large diameter reflectors and refractors to provide uniform lighting and prevent glare, while high bay fixtures usually direct more of the light straight down. Whatever the application, the goal remains to provide the right quantity and quality of light to help people be productive.
It's the duty of the lighting designer to impress upon the client, the plant manager, whoever it may be, how important it is to properly maintain the lighting system. It not only means that the lamps have to be replaced when they should be replaced, it also means the luminaires have to be cleaned at the proper intervals and the room surfaces have to be maintained. When it comes to lamp replacement, it's very important that the lamps be replaced with the proper color, and in the case of HID, it's critical that the lamps be replaced with the proper type, whether they be coated or clear.
Group relamping can be an important part of a maintenance plan. By replacing all lamps at a predetermined time, you can substantially lower your labor costs. And cleaning the fixtures at the same time lets you restore the efficiency lost when dirt collects on luminaires.
We've gone to a lot of trouble to make sure that we have designed a system that uses all of the proper hardware, the proper lamps, and provides the right lighting environment. And if it's not properly maintained, we can lose all of the benefits of that well-designed lighting system. I think in the next 5 to 10 years, we're going to see significant improvements in efficacy, that's lumens per watt, for incandescent, fluorescent, and HID lamps. I think we're going to see developments that will give us lamp efficacies which 5 to 10 years ago would have seemed impossible. I think that we're going to see a lot more application of electronic ballasts in HID and fluorescent fixtures in industrial areas. I think we're going to see an increased use of dimming in the future in industrial spaces. I think that daylighting will be a much more important factor in future industrial lighting. That daylighting, of course, is going to have to be balanced with the electric lighting system so that we are sure that we maintain the proper illuminance levels throughout the day and night within the space. But I do think that we can effect some very significant energy savings by incorporating daylighting into our industrial lighting projects.
To keep pace with the changing workplace, lighting technologies and techniques must continue to evolve.
The ideal would be a lighting environment where the quality of the work performed and the quality of life of the worker come together in perfect harmony, where one reinforces the other. And I believe that excellent lighting can play a major role in this goal.